Spurlock Nation, welcome to Chattanooga. Today it's raining here, but when the video gets released, it could be sunny, it could be raining, we don't really know. But either way, we're having a good day, aren't we, Brent?
Yeah, we are. We're in studio 101 this morning.
Like 101 Dalmatians?
Yeah.
Huh. We really should have waited to do 101 studio when we did the 101th video, but that's not where we are now.
No. I think
We're getting close.
Are we really?
Yeah, we really are.
Oh, goodness.
We're somewhere with the ones that's not been released, 75.
So what's the topic today?
Concrete.
Yeah. Of course.
We're going to do concrete again today, oddly enough. It's like we like the stuff.
Yeah, sort of a love relationship.
Well, I guess when we've been in it for as long as we have, we might as well get used to it and like it.
So today's topic is, what is concrete life cycle and why is it important? You know, we think of concrete as something that lasts forever when we place it. And
well, we hope it does,
yeah.
But reality is it doesn't. You know, we've talked about, I had mentioned in a video that early in my career, when I first started in construction, as I was driving around job sites, we had somebody talking about the buildings that was up before then, the buildings we were testing, and watching them come up and come down in a lifetime is just not what we want. You know, we want our structures to last 80, 90, 100 years whenever possible. When we're talking about sustainability, that is the ultimate sustainability, is
Sure.
to have your buildings last much longer than what they're intended.
yeah, and what do you think, or what do you think we mean when we discuss concrete life cycle? I mean, what is a good definition for us?
Simple definition?
Sure.
Concrete lasts for as long as it is supposed to for its intended purpose. So if they design it for 80 years, the concrete lasts 80 years plus, and is structurally sound enough to continue in its intended purpose, whether it's a shopping mall, a bank, or office building, a parking structure, apartment complexes. I mean, that's really what we're talking about, is for that concrete to last as long as it's intended.
So there's a lot of implications if concrete doesn't last as long as you want it to. A lot of implications to things like life safety, for instance.
Yes.
Things like economic hardships if you have concrete repairs that are unexpected. So that public safety as well as economic sustainability is important, as well as the environmental sustainability. I'm having trouble here today, obviously. The environmental sustainability aspects of concrete lasting a long time. So how do we go about designing concrete for a long life cycle, Josh?
Well, in the past, you know, we just went by compressive strength. And we made assumptions that concrete was going to last 30, 40 years, and we're finding out it's not. And there is now programs that you can look at, that you put in certain parameters, rebar coverage, what your chlorides that will be hitting the concrete is, expectations, the other environmental conditions, and look at how long this is expected to last, whether it's 60 years, 80 years, and then you can do some other things to try to make sure that you're actually getting that out of the design from the Lifecycle 365 or Stadium or other software program.
So the way I like to explain it is the way I used to explain it in the college classes that I was blessed to lecture in was, you know, we've been doing pavement analysis for years and years and years, where we would take equivalent single axle loads or easels and do a pavement analysis based on the number of easels throughout its life cycle before the pavement fails. Right. Well, the idea is it's very similar, except for environmental exposure conditions. So you have a limit of what that environmental exposure can be until it starts doing damage to the concrete, much in the same way as a mechanical exposure like an easel or something like that. So when you have those kind of situations, you can start your design by figuring out how long you want the structure to last. Right. And that can come from an asset owner, usually. And that's a conversation that needs to be had, because a lot of folks just think that concrete lasts forever. And if you can put a number to a target for a life cycle design, then you can start doing working it through the life cycle design process. So then next is you got to figure out what your exposure conditions are. What is this concrete going to be exposed to during its life cycle? Is it salt water? Is it de-icing salts? Is it sulfates in the soil? What other environmental conditions are present that can cause that concrete to have a shortened lifespan? And then you can start looking at a combination of codes and guides and standards and things like that to try to figure out, okay, well, what do I need to do to hit that owner's life cycle he's shooting for? Let's say he wants 75 or 100 years. Right. Here's the exposure conditions. All right, so I have to have this, usually permeability kind of profile of the
Well,
concrete?
then you're looking at like the International Code Council, International Building Codes. You're looking at ACI codes, ACI 201 for concrete durability, and there's plenty of other ones out there that gives you parameters for what you're trying to do. Then you get what you got, talk to your concrete guy, get his materials in, figure out what you got as far as your mix that you're looking at, and run it through that life cycle modeling to see if it's expected to hit that. The beauty of those life cycles, they also give you repair cost as well.
Yep.
So that over that lifetime that it's telling you, it's just giving you your repair cost.
So then if your software doesn't spit out the right number, if you don't come up with the right length of time that your structure is going to last, then what do?
You can go to your concrete ready mix producer or get the materials in and take it to a testing lab, and they can run certain testing such as chloride ponding. They can do permeability results to help give you better information on what that concrete mix will actually do versus assumptions being made, and plug that information into the programs.
You hit on something very, very important, in my opinion, that can be overlooked, and that is talk to your concrete producer. Yes. Those guys know their materials more than any geek behind a computer or anybody else on the planet. They're going to know what their rock, sand, cement, water pozzolans can do when put in certain combinations better than anybody else. So it's always a good opportunity to talk to your concrete supplier.
Well, not only that, but instead of you recommending a 5,000 PSI mix and think it's going to hit all your parameters, if you let them know what your test results you're really looking for, such as your permeability reductions or anything, they can create a mix because they know their materials really well that's going to hit all those with a lot less guesswork.
And if you're still struggling to hit those permeability numbers, what can you do, Josh?
Well, there's a few things you can do, but I personally, there's a wonderful SCP product line that'll help control that. Spray applied after the fact, so even existing concrete, our products can go on and it'll break that interconnected space that we've talked about in the past.
Yep. So thank you so much for joining us today and talking a little bit about concrete life cycle and what we can do to start designing for concrete life cycle. And please comment down below, send us your questions. We're happy to get them. We always enjoy answering them. Thank you so much for joining us. And with that,
like, subscribe, check out our website, and watch us on social media. Thank you.